Good morning, everyone. Happy Monday. It's Ms. K. I'm here with your first video of the week. We are now back to a normal schedule where we will have a video for 6th grade Monday and Wednesday. I'm going to start by going over the second follow-up question. It appears the first follow-up question, there was very few problems on it, so I'm going to skip it. If you have questions on the first follow-up, feel free to email me. Otherwise, for this one, we're looking to form a line segment and find the length of each line. So if I plot A at 3, 5, I'm going over 3 and up 5, making a dot. Then I plot 3, 6, I'm going over 3 and up 6. If I connect it to form a line segment, I can see the line segment is 1 unit. That one is pretty easy. All right, let's look at the next one. I have -2, -3, and -2, -6. So let's plot C and D. So I'm going over -2 and down -3. That's point C, and D is over -2 and down -6. Oops, I'm sorry. If I'm counting the distance of these points, I can see it's 1 unit, 2 unit, 3 units. Okay. 3 units. All right, let's look at C. E is -3, 1. I'm going over -3, up 1. And then I have -3, -1. So let's see, the distance back to the x-axis is 1 from this side and 1 from that side, making the line segment 2 units long. Okay, so now there's going to be no new stuff that I'm going to show you in videos. Rather, problems that I'm going to do, Big Bucky's challenges, are going to be concepts we've covered throughout the year, but we haven't visited in a while. So today we're going to start with a warm-up that says a recipe for salad dressing calls for 4 parts oil for every 3 parts vinegar. How much oil should you use to make a total of 28 teaspoons of dressing? So we're trying to figure this out. This is a ratio problem. Think about the strategies that you know, and then we will go over it in just a second. Now would be a good time to pause the video to solve it. All right, let's try it. So I have oil, and I have vinegar. Okay, and I have 4 parts oil for 3 parts vinegar. And that is a total of 7 parts for this dressing. Okay? But I want the total to be 28 instead. So I want to think about it. How can I get from 7 to 28? I could multiply by 4. So if I do that for every part, I should be able to have an equivalent ratio that's the same. 4 times 4 gives me 16. 3 times 4 gives me 12, and if I check it, I add it up, I get 28. So it says, how much oil should you use to make a total of 28 teaspoons of dressing? You should use 16 teaspoons of oil. We have done this before besides using a ratio table, using a tape diagram where you can draw out the 4 parts of oil and the 3 parts of vinegar, and then do it that way as well. All right? All right. Here's some things I want us to remember. What strategies have we used to solve ratio problems? The strategies include double number lines, ratio tables, and tape diagrams. As I go to present this Buc-ee's challenge, I want you to think about these strategies as we start to solve big problems related to ratios. Here is our big problem for today. So the title is fruit salad. A fruit salad consists of blueberries, raspberries, grapes, and cherries. The fruit salad has a total of 280 pieces of fruit. There are twice as many raspberries as blueberries, 3 times as many grapes as cherries, and 4 times as many cherries as raspberries. How many cherries are there in the fruit salad? Now, this is a big problem that has a lot of pieces of information. So you are definitely going to need to do notices and wonders for this big problem. So what I would like you to do now is pause it and write down everything you notice and wonder. So take 5 and do notices and wonders. You might need to go back to the problem to look at it for notices and wonders. Okay, here are some notices and wonders that I came up with. Let's start with notices. There are 2 times as many raspberries as blueberries. There are 3 times as many grapes as cherries. There are 4 times as many cherries as raspberries. There is a total of 280 pieces of fruit. Sorry, there was a loud truck going by, so I'll read it again. There are 2 times as many raspberries as blueberries. There are 3 times as many grapes as cherries. There are 4 times as many cherries as raspberries. There is a total of 280 pieces of fruit. Times is telling us to multiply. So there's going to be some multiplication element in this. What are some things we wonder? How can I use the total to figure out how much of each type of fruit is in the salad? What ratio strategies should I try? A ratio table? A tape diagram? I wonder what type of fruit will have the most pieces. I wonder what type of fruit will have the least pieces. So here is the problem again. I need you to read it multiple times. Think about ratio strategies we've tried in the past. Double number lines, tape diagrams, ratio tables, and try and use one to solve it. Pause here and solve the problem on paper. Then we will go over it together. All right, let's go over the problem using a ratio table. A ratio table is one of the strategies we always use to solve ratio problems. So as you can see, I created a column for each type of fruit, and then I created a total. At the end, we want our total to be 280. So let's think about it. We said it's 2 times as many raspberries as blueberries. So if I have 1 blueberry, raspberries is 2 times as much. 1 times 2 is going to give me 2 raspberries. Now, 3 times as many grapes as cherries. Well, we don't know anything about the cherries or grapes yet, so let's skip that and come back. It says there's 4 times as many cherries as raspberries. 4 times as many cherries as raspberries. So if raspberries are 2, I can multiply that by 4. It's 4 times as many. I get 8. Now, let's go 1 up. There are 3 times as many grapes as cherries. 3 times as many grapes. So if I know how many cherries there are, I can multiply it by 3, and I get my grapes, which is 24. Now, I can add it up to find my total pieces of fruit. 1 plus 2 is 3, 3 plus 8 is 11, 11 plus 24 gives me a total of 35. We are still nowhere near our total of 280 pieces of fruit. So why don't we try doubling that? We're going to double every line because the ratios have to be equivalent. So if I have 2 blueberries, I'm going to have 4 raspberries. I'm going to have 16 cherries, 48 grapes. I just doubled it. And we know they're equivalent ratios because it's following the same pattern. 2 times 2 gives me 4. 4 times 4 gives me 16, which is 4 times as many, and 16 times 3 gives me 48. So if I double the total, I now have 70 pieces of fruit. Now, this problem says we need to have a total of 280 pieces of fruit. Now, this is a ratio table, and we know what we do to one column of the ratio table, if we do the same to all the other columns, it works. So let's think about this for a second. How do I get from 70 to 280? That's actually pretty easy, because 7 times 4 gives me 28, and then I add a 0. So you see this is 4 times 4. So now if I do this to every row, we can find out how much if I have a fruit salad that has 280 pieces of fruit, how much of each fruit there will be. So let's see, 2 times 4 would give me 8. 4 times 4 would give me 16. Okay, now let's see here. Doing 16 times 4. 6 times 4 is 24. I have 64 cherries. And then I can come back and do 48 times 4. 8 times 4 is 32. 4 times 4 is 16. 16 plus 3 is 19. I have 192 grapes. So this is a way to see if it works. Now, if I add up all these numbers, they should equal a total of 280. So these are 3 examples of equivalent ratios all the way down. The first 2 was the original ratio we came up with. Then we doubled the ratio. Then we quadrupled the ratio to get me a total of 280 pieces of fruit, where you have 8 blueberries, 16 raspberries, 64 cherries, and 192 grapes, which gives you a total of 280 pieces of fruit. All right, so here's the second strategy that we've used before, which is a tape diagram. So it's basically similar to what we did in the ratio table, but we drew it out. So if this is blueberries, if I have 1 blueberry, we talked about this before, we know we have 2 raspberries because it's 2 times as much, right? And then we still don't know how many grapes is cherries that way, but we know that the cherries to raspberries is 4 times as much. So 2 times 4 gives me 8. So this is the cherries. And then 3 times the amount of cherries would give me the grapes, which would need this to be split into 24 pieces, or I'm just going to put under here that this is 24 pieces of fruit. So we have 1, 2, 8, and 24. Okay, so if we have 1, 2, 8, and 24 together, we have 35 pieces of fruit. Now, if we have 35 pieces of fruit, we still need to have a total of 280 pieces of fruit for it to work out. So let's think about it. In a ratio table, we doubled it and then we quadrupled it. Here we could write an equation. We could say 35 times some amount equals 280. Sorry, guys. 35 times some amount equals 280. So now I need to think, how many times can 280 match with 35? So a couple of things we can do. We can roll our numbers. We can see what we would need to do in each example. So in this case, I could divide 280 into 35, or I could just roll my 35. So I have 35, 70, see how many times I could get it. Okay, now we know 70. I could add 35 again and keep going. And eventually we're going to see we can do it out that way, or we could just divide. I have 280 going into 35, which is the opposite. And I believe it goes in 8 times. Let's see. 35 times 8. 8 times 5 is 40. 8 times 3 is 24, plus 4 is 280. So it goes in 8 times. So now, if we know it's going to be 8 times, which is the blank here, this is not clear, 8 times, which is the blank here, we know that 8 can go in all of these boxes. 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8. And here I can do 24 times 8 because I didn't make 24 boxes. Okay, so now let's look at my new ratio. I have 8, 16. 8 times 8 is 64. And now I can do 24 times 8. It's 32. 8 times 2 is 16. Plus 3 is 19. So this is 192. So, what have I learned from this? If I want a total of 280 pieces of fruit, I'm going to have 8 blueberries, 16 raspberries, 64 cherries, 192 grapes, which will give me a total of 280. All right, the last strategy we can actually use to solve this ratio problem is creating an equation, which at the time when we learned ratios in the beginning of the year, we didn't really know how to do this, but now we do. So let's say I have a variable and I call it B for blueberries because blueberries is the 1. We have 1 blueberry. So I'm going to say B for blueberries. Now, if I know blueberries is 1 with a B, 2 times as many raspberries as blueberries, raspberries is going to be 2B. Now, again, 3 times as many grapes as cherries. We haven't gotten to that point yet, so let's skip to the third part. 4 times as many cherries as raspberries. So if raspberries is 2B, then cherries has to be 2 times 4. This would have to be 8B. And now it says there are 3 times as many grapes as cherries. So if cherries is 8B and I multiply that by 3, I get 24B. So now I got a lot of B's. Let's add them up. Remember, B is the same thing as 1B, so we're counting that as 1. B plus 2B is 3B. 24B plus 3B is 27B. And 27B plus 8B is 35B. So these are the total amount of fruits. 35B. Now, we want all of our fruits. Ooh, that's not that clear. Let me try it again. $35B. Okay, we want all of the fruit totals to add up to 280. Now this is an equation. And it's similar to what we did in the tape diagram. So 35B is the same thing as we know is 35 times B equals 280. So now we can think about it. How can we write the inverse or the opposite equation to solve for B? we could say 280 divided by 35 equals B. So what does B equal? B equals 8. So now if we go back, we could substitute 8 in for all the B's. So blueberries would now be 8. Raspberries would now be 16. Cherries would now be 64. And 24 times 8 is 192. Which we learned before, which is the amount of grapes. And then if we checked it, we could add them all up to see if we get to 280, which is what we can do. So now we have 3 strategies that you could have used. You could have used a ratio table, you could have used a tape diagram, or you could have even solved it with an equation. All right, so now that we've solved a ratio problem that had multi-steps, that was giving us where we needed to use the total to find out the specific parts of the ratio, here are some reflections that I have. Ratio tables can be used to represent any kind of ratio situation. Make sure to label the different columns and include the units. So the units here were pieces of fruits. The columns were the different types of fruits: raspberries, strawberries, grapes, blueberries. Tape diagrams are a great strategy to use if we have equal sized parts and have the same units, and the sum of the quantities is important. So here the sum was important. We needed to add up all the different pieces of fruit to get a total. So when we first did it, we got 35. Then we doubled it and got 70 in the ratio table. And finally, we were able to figure out an equivalent ratio that would get us to 280. We can use an equation to solve for one type of fruit and then substitute that number back into the other expressions to find all the fruits. So follow-up. Here is your follow-up question that I would like you to try on your own, and you may use any strategy that you would like. Students surveyed boys and girls separately to determine which sport was enjoyed the most. After completing the boys survey, it was determined that for every 3 boys who enjoyed soccer, 5 boys enjoyed basketball. The girls survey had a ratio of the number of girls who enjoyed soccer to the number of girls who enjoyed basketball of 7-to-1. If the same number of boys and girls were surveyed and 90 boys enjoyed soccer, how many girls enjoy each sport? So my recommendation, make a ratio table for the boys and for the girls. Do not forget totals, a total column, or make a tape diagram and then include a total as well. Now would be a great time to pause the video and try and solve this problem on your own. Questions. If you have questions about anything I discussed or have answers to the problems I left you to solve, please email me or Mr. Lengthy your responses or send us a message on Dojo. I will respond to your messages in my challenge for Monday. Please, please, please email me your responses. I look forward to hearing from you. Miss you all. Have a great Sorry guys, the computer cut me off. Bucky's exhausted from the math, but I meant to say, have a great week. Miss you all.